Okay, so this is a video for question 2. Very short question, fairly straightforward. What this comes down to is, do you know the colours of your precipitates, of your common precipitates, and do you know the solubility of your group 2 hydroxides and your group 2 sulfates? So it tells you that you have got aqueous solutions of sulfuric acid and magnesium nitrate added to separate samples of solution Y. You are asked first of all to identify the group 2 metal. Write an ionic equation including state symbols. I'm going to underline that, that's important. And actually a lot of you, when I'm marking work, a lot of you will highlight or underline that, but then just don't do it. So do make sure you come back to that. For the reaction that takes place when sulfuric acid is added to solution Y. So if we add sulfuric acid to a group 2 ion, we're going to get a group 2 sulfate. Okay, so group 2 metal ion. So we know here that we get a precipitate. What that means is that it's insoluble. Now, if you remember, as you go down group 2, and I still haven't found my periodic table, but I did locate a CGP workbook which has one in it. So as we go down group 2, the sulfates get less soluble. And anyone who has me will know that I always say less, so S, sulfates, less soluble as you go down the group, which means down the bottom here, we don't really include radium, but down here is strontium sulfate and your barium sulfate. Obviously barium sulfate used as a barium meal because of its insolubility. So I'm going to go with barium here. So the group 2 metal ion is going to be Ba2 plus, and the ionic equation, so we just need to put Ba2 plus SO4 2 minus, because that's the negative ion from sulfuric acid that it's going to react with, and that's going to give us barium sulfate, 2 plus and 2 minus, so that's balanced. We said we were going to include state symbols, so we know that a white precipitate forms, therefore that must be solid. Everything else is happening in solution. Solution added, solution Y. Okay. Part B, suggest the identity of the negative ion present in solution Y. So we're adding this time magnesium nitrate. The negative ion is going to react with the positive ion from this solution, that's the magnesium, okay, Mg2 plus, and magnesium will form a white precipitate with hydroxide ions. How do you know that? Well, you need to know that magnesium hydroxide is a white precipitate, but also if you look at group 2, as we go down the group, your hydroxides get more soluble. It's the opposite of the trend for sulfates. So we're most insoluble up the top here. So we're looking for something up here, okay? And so negative ion, what do we say is OH minus. Ionic equation including state symbols for the reaction that takes place. So we have got Mg2 plus in solution plus where are we? What are we adding here? We're making magnesium hydroxide, so OH minus, that's also in solution, I'll come back to that in a minute, is going to give MgOH2, because this is a 1 minus ion and that's a 2 plus ion. That is a precipitate, and therefore we're going to need 2 of those. That's it.